Hello class, welcome to this video on the Spring Challenge Part 4. So we're going to go over some more questions. So starting at number 16, select all true statements. So the legs of an isosceles trapezoid are parallel. All right, so let's talk about that one first. So we got a trapezoid. Remember, a trapezoid is it's a quadrilateral where you have at least one pair of parallel sides. Okay, so you have one pair. So here you go. You got one pair right there. Those are parallel. Those are referred to as the bases. Okay, so that's the base and that's another base. All right, the bases are parallel. In an isosceles trapezoid, the legs are congruent. So that's the leg right there. Okay, so those are the legs. Those are congruent. They're not parallel as you see here. Okay. So the legs of an isosceles trapezoid are not parallel in general, okay? Okay, so it's not that one. A trapezoid is a quadrilateral with at least one pair of parallel sides. That's what we were talking about. Yes, at least one pair. Generally, we think of it as one pair, but technically you can think of it as at least one. And then trapezoid is a quadrilateral with at least one pair of perpendicular sides. No, it's not perpendicular. It has to be parallel. The diagonals of an isosceles trapezoid may or may not be congruent to each other. So if you have an isosceles trapezoid where the legs are the same length, the diagonals are always going to be congruent. So this diagonal is congruent to this diagonal. They're congruent, okay? So if this whole thing is, like, for example, 10 units, then this whole thing is 10 units, okay? Always. So it says may or may not, so that's not true, okay? It has to be congruent. The median of a trapezoid is parallel to the bases and is half the sum of the lengths of the bases, okay? So this is for any trapezoid. So, for example, you could have a trapezoid like this. And if this is 5 and this is, for example, 11, then if I draw a line that is the median, right, or the mid segment, which is essentially a median, it's where it cuts this in half and it cuts this in half, right? Then this is going to be parallel to the bases, so that's true. And it's going to be half. So if I add 5 plus 11, I get 16, and I divide that by 2, then that's going to give me 8. Okay, so it's going to be half of the sum. So that is true. All right, this is called the trapezoid. This is called the trapezoid mid-segment theorem. All right, so you need to write down the true statements, right? And then the notes here, the trapezoid mid-segment theorem and how that works, okay? All right, and then obviously what an isosceles trapezoid is. All right, so number 17, two quadrilaterals A, B, C, D, and A prime, B prime, C prime, D prime are shown on the coordinate grid. Select all pairs of transformation rules that can be used to transform one quadrilateral onto another. So all pairs of transformation rules. Okay, so it says we're going from, now notice that this has the primes, right? You see the primes there. And so that means that this is the preimage. You're going from there to there, okay? So you're going from A, B, C, D to A prime, B prime, C prime, and D prime, okay? So this is referred to as the preimage. This is referred to as the image, the final product. All right, so select all pairs. So let's see if that's true. Now, all we got to do is just apply the rule. And let's pick a point for us to use. Let's use the point D. Okay, D has to go to D prime. So D is 6, 3. Now, if I apply this first rule, actually, let me do this down here. Okay, so D is 6, 3, we said, right? And if we apply that rule, the xy becomes maps to 3 times x, 3 times y. Well, this is x and this is y, right? So we're gonna apply that transformation. So 3 times 6, 3 times 3. Well, that's gonna give us 18, 9. All right. All right, and then we're going to apply the second transformation rule, which is going to negative x comma y. So now this is my new x, this is my new y. So we're just going to negate them, right? So negative 18 for negative x, and then y. So notice that that's negative 18, 9. Now this is not equal to d prime, because d prime is negative 2, negative 1, whereas this is 6, 2, 6, 3. So that means that this cannot be the transformation, right? All right, and then we're looking at the next one. So again, D is 6, 3, and let's say we do the same transformations, 3 times 6, 3 times 3. So we got 18 comma 9, and then we apply this transformation. So that means it's going to be 18 negative 9, which we know is not true. Okay, and then let's apply the next set of transformations. So now we're going to do 1/3 x. So 1/3 times 6. 1/3 times y, which is 3. 6 divided by 3 is 2. 3 divided by 3 is 1. So we got 2 comma 1. Then we're going to apply this rule, which means that x is going to be negative. So we got negative 2, and then y is 1. Now, is that true? Negative 2 comma 1. Or I put negative 2 here. This should say 2 negative 1. Sorry about that. So no, that's not true. It should be 2 negative 1, but we got negative 2, 1. Okay, so it can't be that one either. And then let's try the next one. This is going to be x negative y. So let's see. That means the y is going to be negative. Have a negative there. So we got 6 negative 3. Then we're going to apply this transformation. 1/3 times x, 1/3 times y. So 6 divided by 3 is 2. And then negative 3 divided by 3 is negative 1. So we got 2 negative 1. Yes, that does match up, right? So this does match up. So we're going to pick this one right here. And then let's check the last one. So we got 6, 3. It says select all pairs. We got negative x, negative y. So that means we're going to put a negative on both. Then if I apply this transformation, it's going to turn into negative 2, negative 1. Because I'm going to divide this by 3, and I'm going to divide this by 3. Which is not that. So there's only one answer in this case. All right, so that's number 17. Let's look at number 18. Click to show whether each transformation on a shape preserves the distance or not. Okay, so does it preserve distance? All right, now this right here, I would write this transformation. I would write these transformations on your notes, okay? And then I would say, now, and I would make a little note. Now this is a translation, so let me write, this is a translation. How do I know it's a translation? Because we're adding or subtracting to the coordinates, and that's all we're doing. If you add or subtract to the coordinates, that means that you have a transformation, and that's all you do. All right, so translation, so this is moving to the right 3. Remember the translation, it works like this, x plus or minus a, y plus or minus b, and if you're doing plus a, that's moving to the right. If you're doing minus a, where a is a number, you're moving to the left. If you're doing plus b, you're moving up. And then if you're doing minus b from y, you're moving down. Okay? This is equivalent to the translation vector AB, right? Which means that if it's positive a, you're going to the right. If it's negative a, you're going down. Plus b, you're going up. Minus b, you're going down. All right? So in this case, the translation vector for this example is 3, 0, because you're not moving in the y direction at all, but you are moving in the x direction to the right. Okay, so you should know the difference between the transformation rule and the translation vector. Okay. All right, so does it preserve distance? The answer is yes, because the translation is a rigid motion. Okay, you have 3 rigid motions, also known as congruence transformations. Congruence transformations. Congruence means congruent, meaning that they're the same, meaning that the preimage and the image are both congruent. So 3 different ones. You have translations, which simply move a figure across the page in some way. And then you have a reflection, which is just flipping the figure, so it doesn't change the size. and then you have rotation, which simply turns the figure. Those are 3 rigid motions, and they all preserve distance and angle. Okay, the only one that the transformation, then we have, this is versus similarity transformations. Similarity transformations, sorry about the writing here, my pen. All right, so similarity transformations, we are like dilations, for example, or dilation plus rigid motion. Those are similarity transformations, but they preserve angle but not distance. Preserve angle, not distance. So it's good to know the difference between those two. Now this right here, this rule is a dilation, because you're dividing by the same number, right? Divided by 3, things like that. And so when you see that, that means it does not preserve distance, okay? And then this one does. All right, so all that just to say that, but we did want you to know the different transformations. Now, number 19, look at the square on the coordinate grid. All right, the list of transformations apply, hold on here. Let me make sure, okay, make sure everything's good. Let me undo that movement. Okay, so it says the list of transformations apply to the square ABCD in sequence. Hold on, let me give it a second here. I want to move this back to where it was. Okay. All right, that's better. Sorry about that. Okay, so the list of transformations applied to the square ABCD in sequence is shown. Rotate 90 degrees clockwise, and then dilate by a scale factor of 2 with origin, and then reflect across the line y equals x. Draw the resulting square on the coordinate plane. To draw a square, okay, so we're just going to draw it on here. All right, so let's apply all the transformations. This is number 1, 2, and 3. Now, rotating 90 degrees clockwise around the origin, write down the rule for that. The rule for that is you're rotating clockwise, so you're rotating this way, right? That means it's going to look like this, y, x, and then which one's going to be negative? It's going to be this one, okay? So it's y, negative x. And then that's the rule for that. Now the rule for dilation, we're dilating by a scale factor of 2. That means we're going to take the coordinates and multiply both of them by 2. Right? And then the rule for reflecting across y equals negative x is we take the xy coordinates and then we negate. Well, first off, we switch them. We switch the y and the x, and then we negate them. Okay, so it looks like that. All right, so let's apply those transformations. Let's do it for a. So a is negative 2, 2. Let's apply the first transformation. The first transformation, you switch the coordinates first, which is going to be 2, negative 2. Then you put a negative on the second coordinate. So I'm going to put a negative there, but then that makes it turn positive, right? So I'm going to put just 2, 2. Okay, so I'm showing you my steps. The second step, the transformation, you're going to multiply each thing by 2. So we got 2 times 2, and then 2 times, I'm just going to do times 2 and then times 2, right, for that. And rather than doing it here, 2 times 2 is 4, 2 times 2 is 4. All right, then I'm going to do the last transformation, number 3, which is you switch, then negate the coordinates. So switch them, then negate them. So negative 4, negative 4. So that's going to be point A, negative 4, negative 4. I'm going to do that here. Negative 4, 1, 2, 3, 4, negative 4, negative 4, 1, 2, 3, 4. All right, so that's negative 4, negative 4. That's A prime. All right, now we're going to do the next one. So B. B is 3, 2. So applying the transformation rule. Remember, switch them, then negate the second one. So 2, negative 3. Then multiply them by 2, so times 2 times 2. And then you get 4, negative 6. Then switch them again and then put negatives on both. Now I'm going to put negatives, minus, minus. So this turns positive. So I got positive 6, comma, negative 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So positive 6, negative 4. So this is B prime. All right. And then we only have to do one more, really, and then we know where D is. All right, so C is 3, negative 3. All right, so first transformation, switch them, put a negative on the second one, so negative 3, negative 3. Then times both of these by 2, so times 2 times 2. 3. That's going to be negative 6, negative 6. Then the last transformation, switch them, then put negatives on both. If I put negatives on both, then these are going to be double negatives, which makes it positive. So I got 6, comma, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So here we go. And if that's C prime, then that means D prime has to be here by default, okay? For a square. All right, so there's your transformation with those three. All right, let's do the last one here. All right, the graph shows the triangles ABC, PQR, and KLM. All right, so we got the triangles ABC, and we got PQR and KLM. Select all statements that explain why triangle PQR is similar to the other triangle. Okay, so it says triangle PQR can be mapped onto triangle KLM on dilation by a scale factor of 3, centered at 0, 0, then followed up by a reflection over the y-axis. Okay, so there's a lot of stuff going on here. So let's see, PQR. Let's just test one of these. So PQR, the coordinates of R are 3, 1. Now let's see, that should map onto, it says R, it can be mapped onto M, right? So it should be mapped onto M, okay? So let me say R goes to the M. Now let's see if that's the case. It says you're gonna dilate by a scale factor of 3. That means you're gonna multiply the coordinates by 3, okay? So we got times 3, and then times 3. So that's gonna be 9, 3. When they say centered at 0, 0, you're just multiplying the coordinates. Followed by a reflection, so we're going to do a reflection now. Reflection of the y-axis means that you're going to have the x being negative, all right? So that means it's going to be negative 9, 3. Now, is that the same as the coordinate m? Well, this is negative 9 and 3, so that looks good. And if I did that for p, which is 1, 1, that would be 3, 3, then it'd be negative 3, 3. Okay, so that would work. So this looks good. I'm going to check that. Okay, so that can be mapped onto that. Now let's look at the next one. Triangle PQR can be mapped onto KLM on dilation by a scale factor of 3, followed by 90 degrees clockwise rotation about the origin. We just did the scale factor of 3, so we know that that works. Now, does it work for a 90-degree rotation? Well, the rule for 90-degree rotation is it's y, negative x, which is not the same as that, right? So it can't be that one, because if we did that, it would contradict what we did there. Okay, so it's not the second one. Now PQR can be mapped onto triangle ABC by 90 degrees clockwise rotation. Okay, so there's that rule, the first one, which that first rule, 90 degrees clockwise about the origin, is y, negative x. And then followed by a translation. So we're doing a translation. So that means we're going to add 4 to x, because it says add 4 to the right, and then 5 down. 5 down meaning subtract 5 from y. So let's do that for r. R is 3, 1. If I do the first transformation there, I have to switch the coordinates y, x, and then put a negative on the second one. So it becomes 1, negative 3. Then I need to add 4 and then subtract 5. So plus 4 minus 5. So that turns into 5, negative 8. Now that is definitely not the same Well, let's see. Actually, it says PQR can be mapped onto ABC. So this time R has to go to C. That's what it says, okay? So is that the coordinates of C? Now C is 5, -8 based off of this picture. That's what I get. Okay, so that's good. All right, so that looks pretty good. So I would say yes to that one. Then let's look at the next one. It says PQR can be mapped onto, oh wait, I just did, not that one, I'm sorry. I just did this one. So write down the ones that are true. The PQR can be mapped onto KLM on dilation by a scale factor of 3. So PQR onto KLM by a scale factor of 3. That's what we did in here, right? Remember, we did that there. Center at 0 is followed by a 90 degrees counterclockwise rotation. The rule for 90 degrees counterclockwise is negative yx. But again, that's going to contradict what we did here, so that cannot be correct. PQR can be mapped onto ABC by 90 degrees counterclockwise. Okay, so and then followed by translation 4 to the right, 5 down. Now we just did the 4 to the right, 5 down. Does it work for counterclockwise rotation? Well, counterclockwise rotation is, we just said it was negative yx. So let's try that with R. R was 3, 1. If I apply that, I had to switch them, put a negative on the first one. Once I switch it. So there, that's what I get. And then we're gonna do 4 to the right and 5 down. So it's gonna be, oops, and not to that one. I gotta do 4 to the right and 5 down. So negative 1 plus 4, and then 3 minus 5. Now that is definitely not the coordinates for C, so it cannot be that. So we only have 2 choices here, okay? All right, that's gonna do it for the video, guys. Hope you found this useful and informative, and as usual, I'll see you in the next one.